Hello, trigonometry students. This is our last required lesson for the course competencies. This lesson is on operations with complex numbers. So in the previous lesson, we just talked about how to take a complex number in standard form, a plus bi, and how to graph it, find its magnitude, find its angle, and write it as a trigonometric number. So now we need to do multiplication, division, and powers using these numbers. So we're going to start this notes with an algebraic review of multiplying complex numbers. If you had z1 equals 1 plus I, and z2 equals 5 rad 3 minus 5i, and you wanted to multiply them, you would just use parentheses, and you would distribute each term for 4 terms total. So we're going to do 1 times 5 radical 3, 1 times negative 5i. Then we're going to come down and do I times 5 radical 3 and I times negative 5i. Now in your algebra class, you hopefully learned that I squared should be replaced with a negative 1. So this last term is actually negative 5 times negative 1, which is positive 5. And we get the solution 5i rad 3 plus 5. Gathering this to be a plus bi form, your a are your terms without I, so that in this example is 5 rad 3 plus 5, and your b's are the terms with I, which in this case, and I'm going to switch the order a little bit, 5 rad 3 minus 5i. So this would be our final answer. And that's the algebraic approach. Now we need to take a look at the trigonometric approach to multiplying numbers. So the first thing you need to do is get each value in trig form by finding the r magnitude and the theta angle formed with the positive x-axis. So the first one we've got is r1, which is going to be the square root of 1 squared plus 1 squared, since these are the coefficients a and b. That gives us the square root of 2. Then we want to find theta 1, which we talked about in the last lesson as being the inverse tangent of b over a, and then adjusted to be in the correct quadrant. So this here is in quadrant 1, since it's the point 1, 1, which means when I do the inverse tangent and get 45 degrees, I know that it's already in the correct quadrant. Then we have z2. For z2, the magnitude is the square root of 5 rad 3 squared plus negative 5 squared. And I'm actually going to simplify this by hand. It depends on your calculator's capabilities. We do want to leave our answer as exact as possible. So this is the square root of 25 times 3 plus 25. Which means it's the square root of 100, which means it's a perfect exact 10. And your calculator should be able to handle that all at once. Finally, we have theta 2, which is the inverse tangent of negative 5 over 5 radical 3. And we can type that into our calculator to get our exact answer, if there is an exact answer. I'm getting negative 30 degrees. Now the problem with that is that negative 30 degrees is in quadrant 4. But our angle, if we were to graph this, would be positive, negative. Oh, that's not a problem at all. That is in quadrant 4. So you always want to check that those jive. Since negative 30 is in quadrant 4, and our answer should be in quadrant 4, we can leave these angles like this. So that's step 1, is just getting all the trig parts. And then step 2, we have this beautiful formula for multiplying complex numbers, where you just multiply the r values. So we're talking about 10 rad 2. And I'm going to use shorthand notation. So I'm going to use SIS, CIS. And then you add your thetas, which our thetas in this case are 45 and negative 30. So our final answer is 10 rad 2 cis 15. And that's how you multiply in trig form. With this being said, make sure whatever angle you have in your formula here is positive and less than 360 degrees. So if you get a negative, add 360 till it is between 0 and 360. And if you get a number larger than 360, subtract 360 until it is on the unit circle. And so that's just using your coterminal angles, since the period of sine and cosine is 360 or 2 pi. Next example, we want to use trig form. So I'm going to copy down that formula, which was R1 times R2, CIS for shorthand, theta 1 plus theta 2. Well, this problem is provided in trig form. So here's R1, here's R2, here's theta 1, and here's theta 2. All we have to do is 10 times 2, and then CIS 10 plus 200. And make sure you're adding those angles and not multiplying them. And that's actually how you would leave your answer. Now, test directions come in two forms. It might ask you to leave your answer in trig form. It might ask you to leave your answer in standard form. If I'm asking for standard form, just remember from the last video notes that you're going to do the magnitude times cosine and the magnitude times sine. So in this case, it would be 20 times cosine of 210. 210 is on your unit circle, and cosine of 210 is negative 1/2. Minus 20 sine, and again, I know that 210 is in quadrant 3, so I know they're both negative. That's why I'm putting the minus here, as opposed to putting the minus right here with an I. So my final answer in standard form would be negative 10 minus 10 rad 3. And that's multiplication. After multiplication comes division. So division in algebra is a little more complicated than multiplication because we've got our ratio, and we're basically going to use the conjugate to rationalize the denominator, and that is how we learned to divide complex numbers in algebra. So I'm going to distribute this. That's going to give me 3 minus 9i minus 2i plus 6i squared over 1 minus 3i plus 3i minus 9i squared. Remember, I squared is a negative 1. So up in the numerator, we have 3 plus 6, which is 9. So I'm combining these terms here. And then we have a minus 11i over, these cancel, so we have 1 plus 9, which is 10. And if we switch this into a plus bi form, we would write 9/10 minus 11/10 I. Let's compare that with the trig equivalent. To do trigonometric form, you're going to need to know R1, R2, theta 1, and theta 2. So R1 is the square root of 3 squared plus 2 squared. And that 2 is negative, but since you're squaring it, it doesn't make a difference to your solution. I'm getting the square root of 13. R2 is 1 squared plus 3 squared, which is also the square root of 13. Theta 1, and I want to think about the quadrant, so I'm going to switch colors here. 3 is plus minus, which is quadrant 4, which should be fine with my calculator. And this one is plus plus, which is quadrant 1, so actually both of these should come out perfect in my calculator. So theta 1, if I do inverse tangent of 2 over 3, it's definitely not on the unit circle. I'm getting about 33.7 degrees. Oh, hold on, wrote that incorrectly. 2 over 3, and it's negative. I'm getting negative 33.7 degrees. I feel like I've done something incorrectly. So let's go back. 1 squared plus 3 squared should be the square root of 10. Okay, feel better about that. Don't jump into the comments right away. I noticed it. Now we've got the inverse tangent of 3 over 1, also not on our unit circle. So we're going to be rounding our answer, and I'm getting 71.6. And so we've got a quadrant 4 angle that matches and a quadrant 1 angle that matches. Plugging these into the formula, we get z1 over z2. And remember, this is now division and subtraction. So it's the square root of 13 over the square root of 10. CIS, for shorthand, theta 1 minus theta 2. And that is negative. So we're doing negative 33.7 minus 71.6. And that gives us negative 105. As I said in the last example, don't let this be negative and don't let it be more than 360. So we're going to add 360 to this angle. And we're going to simplify this radical by rationalizing it. That gives me the square root of 130 over 10 by multiplying numerator and denominator by rad 10. CIS 254.7. Well, let's compare these answers. This is the trig form. This is the complex standard form. This one is about 0.9 minus 1.1i, if I round it to decimals. Over here, I'm going to do the square root of 130 over 10 times cosine of 254.7, and I'm going to get a totally different answer. Okay, looks like I made a mistake much earlier in the first problem, and I need to correct it. I think it's a handwriting like typo issue. So if we're looking here, we had negative 2i times negative 3i, which becomes plus. So this is actually 3 minus 6, which means that this is actually negative 3 here, which means this is negative 3/10 right here. And then this isn't 0.9, this is negative 0.3, because then when I type this in my calculator, this is my concern, is they should match, and they didn't. So notice that doing the algebra is a great way to check your solution. But this should be negative 0.3, which is what I get from my calculator. I get negative 0.3008. And then if I do sine of 254, I get negative 1.099, which rounds, and we get the same answer for both. So glad I caught that error. Let's finish up with one more division example. This one's much easier. So we have our r's in the front, and then we have our theta 1 and our theta 2. And so we're just going to combine them into our trig formula, which is 4 over 8 CIS theta 1 minus theta 2. And so that gives me 1/2 CIS of negative 90. Go ahead and add 360 to that. We get 1/2 CIS of 270. So if we were going to put this in standard form, 270 is on your unit circle, so I expect clean answers. What's cosine at 270 degrees? And what's sine at 270 degrees? And so this answer is just negative 1/2. For a fairly complicated question, when you use trig form, you get a really simple answer. All right, last example. So this video notes is a little bit longer than the last one. Demoivre's theorem for powers and roots has its own formula, and we have the same requirement. We need to know the magnitude, we need to know the power, and we need to know the theta. Now, if you can imagine doing this in algebra, 2 minus 2i to the 10th, unless you remember your binomial expansion theorem, this is not a simple question. So we're going to start by finding r. R is 2 squared plus 2 squared. And we've done this example before. That gives you the square root of 8, which simplifies to 2 radical 2. Theta is the inverse tangent of y over x, which is negative 45, which is quadrant 4. And this point is positive negative, which is also quadrant 4. So that jives. And then the answer for z to the nth power is just 2 radical 2 to the 10th power, CIS 10 times negative 45. So see if your calculator can handle 2 radical 2 to the 10th power. Make sure you use parentheses around that term when you type it in so that everything gets the power. So it works. I'm getting 32,768. CIS, I'm going to just invade that space. Negative 450. Well, negative 450 is way too negative. So we're going to start by adding 360. We get negative 90. We need to add 360 again. And so we're going to get 270. 32,768. CIS 270 degrees. Break that down. This is very similar to the last problem. 270 is the ordered pair 0, negative 1. So we're going to get 0 minus 32,768i. And that's our final answer for this expression raised to the 10th power. In the second one, we don't have to convert it to trig, so it's a little bit easier to identify. We're going to do the the magnitude to the 5th power, CIS, 5 times the angle. So what's 5 times 120? I'm getting 600, which is bigger than our unit circle. So go ahead and subtract 360 to find a coterminal angle. We get 5 to the 5th, which is 3,125. CIS, 240 degrees. So this answer is going to be a little uglier than the last answer. This is the answer in trig form. If we break it down to standard form, we've got negative 312, no, that's an equal sign. We've got positive 3,125 times the cosine of 240. Cosine of 240 is negative 1/2. And then we've got 3,125 times the sine of 240, which is negative rad 3/2. So that actually doesn't really simplify any nicer than that because it's not divisible by 2. For the last example, cube roots look like this. And we learned in algebra that that's the same as saying the 1/3 power. So this is the same question, except n is equal to 1/3. Let's find r, which is negative 2 squared plus negative 2 rad 3 squared And so what I'm doing is I'm typing this in my calculator without the square root over the top, just to see what the inside, oh, it's a perfect square. So it's a square root of 16, which means the magnitude is just 4. Beautiful. Then theta is the inverse tangent of negative 2 rad 3 over negative 2. We really want to pay attention to this one because this is the first problem we've had that's not in quadrant 1 or quadrant 4. This is actually in quadrant 3. So when we type this in our calculator and we do our inverse tangent, we get 60 degrees. Well, 60 degrees is not in quadrant 3. It's in quadrant 1. So if I want it to be in quadrant 3, the period of tangent is 180, and I can just add 180 to the 60 degrees. So my angle for this problem is 240 degrees to be in quadrant 3 and match our actual complex number. Finally, we're ready to answer the question. So we're going to take r to the nth power, and then we're going to and then we're going to have 1/3 times our angle, which was 240. Now, when you look at this formula, I think this is on your formula sheet, you're going to see it's like over n or something like that. And I'm just going to break down all those parts of the formula with an explanation. So the reason it's over n is because 1/3 is 1 over n, where n is 3. So this comes with a big warning. We've got the cube root of 4, CIS, and 1/3 of 240 is 80 degrees. But we're trying to find the cube roots, and this is only one of them. How do we find the other three? Well, if you remember from solving equations, at the end of an equation, when I was trying to find all solutions, I put plus or minus 360. And so that's going to be the secret to finding the remaining answers here. Except we're taking 1/3. So I don't want to do just plus or minus 360. I want to do plus or minus 1/3 of 360. So my next answer is 4 to the 1/3, CIS. And depending how you want to write this, you can write 1/3 240 plus 1/3 360, or you could write 240 plus 360 all over 3, which is how the formula is written, or you could separately figure out what 1/3 of 360 is and just add that. So 1/3 of 360 is 120, 1/3 of 240 was 80, and our second answer is the cube root of 4, CIS, CIS 80 plus 120, or CIS 200 degrees. And then I am continuously adding 120 degrees to this problem because I'm going to add another 360 1/3 and another 360 1/3, etc., until I have all three answers. So now I'm just going to shortcut it. It's going to be the cube root of 4, CIS, add another 120, and you get 320 degrees. And so these are your three roots, which you can then turn into standard form. And I'm kind of running out of room here. But we know that to convert it to standard form, we would just do the cube root of 4 times cosine 80, and the cube root of 4 times sine 80, and the cube root of 4 times cosine 200, and the cube root of 4 times sine 200, so on and so forth. So I'm just going to leave these answers like this, and this is the end of your video notes. Thank you for watching.